Hello students, welcome to CBSE Science series. We already studied about experimental study of photoelectric current. In that topic we studied that photocurrent can be varied by changing the intensity or frequency of the incident light and the potential across the emitter and the collector plate. And we also studied that the effect of intensity of light on photocurrent means when the intensity increases, the photocurrent increases, and we know that photocurrent is directly proportional to the number of photoelectrons. So when intensity increases, the number of photoelectrons emitted by the emitter plate increases and the current increases. Now what happens to the photocurrent when the potential across the emitter and the collector plate is varied? Means we are going to change the polarity of the emitter and the collector plate, and we are going to measure the photocurrent. To study the effect of potential on photocurrent, first we connect the positive terminal of the battery to the plate A. Plate A means collector plate. Collector plate attracts the photoelectrons and negative terminal is connected to the plate C. Plate C, we know that emitter plate, it emits the photoelectrons when the light incident on it. And the collector plate is connected to the positive terminal and the emitter plate is connected to the negative terminal of the battery. Here we are going to change only the potential across the emitter and the collector plate. We are not going to change the intensity and frequency of the incident light. Means the frequency and the intensity of incident light is fixed. If the potential is increased at the plate A, the current increases. The plate A is connected to the positive terminal of the battery. That is, collector plate is connected to the positive terminal of the battery. We know that the collector plate attracts the photoelectrons emitted by the emitter plate. So when the potential increases at the plate A, that is when the potential increases at the collector plate, it is connected to the positive terminal. So we are increasing the positive potential at the collector plate. What happens? It attracts more number of photoelectrons. It accelerates the photoelectrons and the current increases. And if we increase the positive potential further, the current increases and it reaches the saturated value. We know that the maximum photocurrent is the saturated current, because at this stage the collector plate attracts all the photoelectrons emitted by the emitter plate. Then no photoelectrons move towards the collector plate and the current becomes the saturated value, and the maximum value of the photocurrent is the saturated current. If we do the same experiment for higher intensities of the incident light, we know that the current increases because the current is directly proportional to the intensity of the incident light. Means when the intensity increases, the number of photoelectrons emitted by the emitter plate increases and current increases when the positive potential increased at the collector plate. What happens if the collector plate is connected to the negative terminal of the battery and the emitter plate is connected to the positive terminal of the battery? That is, the collector plate will not attract the photoelectrons. It repels the photoelectrons. So the photocurrent decreases. If the negative potential at the collector plate increased further, no photoelectrons reaches the collector plate and the photocurrent becomes zero. At this stage, this negative potential is known as the stopping potential, because no photocurrent in the circuit, means no photoelectrons move towards the collector plate. So the photocurrent is zero at this negative potential. It is called stopping potential. And if we do the same experiment for different intensities, that is for higher intensities, it is found that the negative potential is same for higher intensities of the incident light. The negative potential is not varying when the intensity of the incident light is increased. So when the intensity of the incident light is increased, the current is increasing, the negative potential is not varying. The negative potential is independent of the intensity of the incident light. This is what about the effect of potential on photocurrent. Thank you.